Yeah, hi. Okay, so you're only two. I suppose on the previous class you could be kind of the full group, right? Um, I'm just thinking like probably we have to wait for someone else, and kind of we have a minute more till the beginning of the class. Okay, but guys, maybe while we're waiting for others, so do you have any questions about previous material? Maybe you tried that regex at home, and maybe I mean besides the classes, and maybe you get some questions.
Not really, I guess.
Okay, okay, makes sense. But you tried them, right? Did you? Mm-hmm. Okay. All right. So now it's 5 and 10 minutes. Well, I guess we have to be starting. Um, all right. So I opened materials which we are gonna overlook today, and as all the time, uh, we'll be working in a way that I'm sharing the screen. Okay, so screen is shared, and we are moving for the Windows system, which has a Python. Mm-hmm. Okay. And yeah, and we have at least such files to take a look at. There will be several examples of some of the basic codes, how to implement them, and actually, since it's not very complicated, we can even find out some way to make them more maybe complicated. And we'll take a look on, from my perspective, the really necessary topic um, about the graphical side of the Python, because in most of the cases such thing is kind of ignored by a lot of teachers who trying to run classes about the Python. But as you know, if we can work, if we can create something that's visually looking nicely and moreover corresponding to the nowadays systems, that will be more preferable for that application users, right? Because if we will compare, let's say, SCMD applications and the graphical ones, which one will be chosen by nowadays users? Well, definitely applications with the graphical side, where there are some buttons, pictures, and so on and so on. I suppose everyone will agree about this. So that's why, from my perspective, it's one of topics which should be firstly overlooked. Um, Surely after the syntaxes. All right, so let's start with presentation three, and let's go then to the presentation four. All right. So since I already have these files, yeah. So here I will just open them. Yeah, like this. And since I will be showing you how these things are working, I will be using, well, literally the same folder I created recently. Uh, where was it? Was it in downloads? Ah, yeah. Okay, so, and I will be just, editing the same file and just running the file from the same folder. Okay, so the first example will be, and by the way, we'll be taking a look on some new syntaxes features. Okay, so right now we'll try to get a specific set of symbols from a text or from the word, it doesn't really matter. And here we have several ways how to implement this. Well, the first of all, everyone could say that like, okay, we have to go through the text and we have to be finding out if the certain symbol is inside some of the arrays of symbols we're looking for. How this could be implemented, let's say, in a one row. By the way, we will be able to split this command in several lines, but Python allows us to implement complicated constructions in a very simple manner. For example, here we have a function. Since we remember that def means a function definition, nextly we have a definition of oh, nextly we have the function name. Then we have um, one argument name, and then we're starting the function itself by using a so-called code block, right? And we're given back by return a result, which literally is formed in a such complicated manner. But this writing form literally is pretty tricky. Also, we can analyze what we have here, and the story here is pretty simple. So the first of all, we have brackets, right? Moreover, square brackets. That automatically means that the result will be an array. And well, let's call it better a list. And since the resulting thing is a list, then we can create a list by a complicated structure. Well, which one? And here we have yeah, and here we have a construction, well, which literally says that we are putting in the array a variable called each. Well, in place of which we could write whatever other name if we like, but that name should be corresponding to the rest of the equation. That's what I just highlighted. And here we have a source this each comes from. Here we have once again a complicated definition, which literally has that there is variable each. That's iterative variable since we're using for in, right? So by this part, we're going through all of the elements of the list, and the string in this case a priori means for us that that will be the text. So each is related to each symbol of the string, and moreover each symbol of the string will be checked like if that symbol is inside a text. So as you remember, guys, from previous classes, we have operator in that literally checks if the thing on the left is located in the thing on the right. So literally, if each is located in this set of symbols, then this each will be given back as the result of that operation, and literally, um, there will be a collection of such eachs, right? And they will form an array because the array literally wraps this result. Well, this is pretty maybe complicated, but if we would try to rewrite this, and by the way, we can check primary if that works, and then we can think about how we would be able to rewrite this. Maybe finding out kind of a normal form of this. Okay, so we have it, right? Um, and let's maybe run it and let's see if we will get such a results we have after the comments in the code. Okay, well, I will be running the terminal. Okay, and I'm running the Python file. Um, okay. Yeah, so in this case, since I don't have the printout, then I don't have the result. And since we are not using the Python's terminal, then we don't really have this printout on the screen. Okay, so I have to add the print function, right? And let's try the same code as well again. So we have those two results. We can compare them to what we got in the comments, right? And yes, so we got the correct result. Okay, so there could be a question like how to make this maybe more obviously looking for us because again this construction is pretty complicated. So let's maybe try to modify it somehow. Well, I would say that primary, since we would be, for example, collecting the list, right? We would need the list to fill with such symbols, and surely we could create an empty array, for example. Um, sorry, the empty list, because we have literally three types of arrays. We can even make a list, right? Or we can just write these square brackets. That could be enough. And nextly, we would need to have this going a symbol by symbol, and then we would need to have such comparison, like if that particular symbol is located in the text, right? And if it's so, then we would need to add that each to the resultant array, and that array will have to be given back as the result of the function. Okay, I really hope I didn't make any miswritings here. Let's run it. Yeah, and you see, oh, we got the same result. Yeah. So as you see, that complicated writing form can be just written. Um, okay. Are we good so far? Is this one is good for us? Is it understandable? Right?
Yeah, it's understandable.
Okay. All right. So all the rest parts will be kind of more kind of easier. For example, here we have a so-called capitalized function, but in the result um, it literally replaces the first letters of textual of word type symbol um, chunks with the uppercase letter. So literally everything that's considered to be a word will be converted, like first symbol will be replaced by the uppercase. Well, I don't think that this part should be maybe pretty overlooked, but we can take this and we can maybe print out all the results. Mhm. Yeah, and you see that works pretty normally. Okay, now let's go further. Well, here we have a pretty simple thing like a multiplication by something. Well, I would say we overlooked this thing uh, previously, but let's maybe try it just in order to see that it really works. Okay, so we have what will be multiplied? We have the multiplier itself, and we're printing out the result of multiplication. Okay, so we got this. So we have 5 times hello world written on the screen. Well, very simple. Let's maybe go further. And here we have one of really famous and popular thing in the Python, like dictionaries. Well, I could name this as the combination of the key and the value of things. And literally, this dictionaries is a kind of, like an array within which each of the indexes can be named not only by the number. Okay, so here we have a dictionary which are created in a such way. So dictionary 1 has indexes of 1, 2, and dictionary 2 has indexes of 3, 4. We can get access to them. And we can even merge them, by the way, like merging the arrays, right? Um, so what we'll be getting? We'll be getting dictionary 1, dictionary 2. We'll be making a new dictionary, which will be a full copy of the first one, and then we'll be updating the keys. Well, updating the keys literally means that if we in dictionary 2, in this case, we have indexes which already placed in the dictionary tree, then they will be replaced. If those are new ones, and surely this consideration of if it's old or a new one comes for every of index value pairs. So if it's something new, then it will be just added. And we return back as the result of the function the new created dictionary. Okay, let's see how that works. Let's take the code, let's put that in the file. Okay, let's make the same offset for comments of the function, and let's then print out what we get after merging both of dictionaries. Okay, so let's see if we will get all of those four indexes. Yes, we have them. Okay. Um, yeah. Sometimes you would need to calculate maybe an execution time for your codes, especially for the cases you would like to optimize your code probably. So for that purpose, you can use the timing library, which is located in the folder time in installation path, and then we can use a time.time function, which literally gives you a time moment, and then you can make their differences, and you can find out the time spent for the code. Surely this code will give us kind of a zero. It's just a priori known because here we don't have much of operations. Well, surely we can try this one, but the result will be a zero. That will be pretty understandable. But anyways, we can take a look. Well, yeah, as I said, it will be zero. Surely, if there would be some calculations, um, well, we can make some calculations. Um, um, for example, we can do something like this. So we'll have 1,000 iterations, and on each of them we will be running the function itself. Maybe in this case we will get some of the timing. Well, not really. Surely we can increase this iteration amount. Still a zero. Um, I suppose we can make something like this maybe, just to see that we have some of the results. Oh, okay. That already takes really um, a lot of time. Okay, this is still pretty long, so I will just reduce it um again. Okay, let's reduce it in a such way. Oh, actually, it had to show the result. Okay, I got the point why it happens because the final timing is taken before the execution. Okay, so let's run that again to see if it gives us some results. Yeah, so you see, we got the result. So for optimization purposes, you can use this thing, and it really, by the way, helps. Okay, well, what else can we get from all this? Oh, okay, the SOAP algorithm, but I suppose you remember this thing, but just in case, let's take a look and let's try it really how that works. So A is 3, B is 4, and after the swapping, we have to get 4 and 3 instead of 3 and 4. Let's see how that works. Okay, so as you can see, A is 4, B is 3. Like it has to be after the swapping by our algorithm. Well, pretty simple, and in such cases, you don't really need to use some additional variable for swapping values. It's pretty easy to do within this programming language. Okay, duplicates. So we can find out if two arrays are equal. Well, how we can do that? Or let's say if an array contains uh, duplicates of the elements. Let's formulate this in a such way. So um, since we are capable to make transformations of lists, sorry, of sequences, and we have not only sequences which are mutable, immutable, but we have even spatial sequences like set, we can use a set. So when we convert a sequence to the set, literally all the repeated elements will be vanished. So in this case, if only a size of the array is same before modification and after converting to the set, then all of elements are unique. And if it's not so, then it's not unique. Okay, so our function is to check duplicates. So it gives us true if there are duplicates, and it gives us false if there are no duplicates. So the first case gives us true, so there are elements with the same values, like 4 and 4, and the rest two arrays they are containing unique elements. Okay, let's see how that works. Let's take the codes. Let's use the printing function. Mhm. And let's run the code itself. Yeah. So as you can see, this thing really works. So I would say in most of the cases, um, oh, one of students disappeared. Okay, because previously you were three. Um, okay. So as you can see, guys, in some of the cases, we don't really need to go through the whole array. We don't really need to calculate something because there are functions that literally helps us to find out a solution, like this one. Um, okay, filtering the false values. Um, well, this is pretty interesting example. And here the main thing is that we use a filter. Filter literally um, finds out a so-called elements which are convertible, and in this case I would really like to highlight this, convertible to the Boolean false. Um, this means that um, the values and literally it could be the text, it could be the object, it could be the reference, it could be a digit or a number. They all are convertible. And based on the rules, we can get always true and false. For example, numbers, right? If we would consider talking about the numbers, which number gives us value false? Well, there's only one such. It's a zero, and all the rest give us true. For the text, right? So the question for you guys, which text in the conversion gives us value false? What kind of the text does it?
Uh, Boolean?
I
Wha-
mean,
wha-
what should be in that text?
Something that is not true?
Um, which, well, it's what convertible to false, right? And there is only one case when text will be converted to false. Only one, uh, s- only one single case when your text doesn't contain any of symbols. So it means you have a quote and then you have another quote. That's it. Makes sense, right?
It does. It does make sense.
Well, the same conversion is always used in JavaScript, for example, or in a C language, or maybe C++, C Sharp, and others. This is really a general thing. Okay. Well, sometimes, especially when you're thinking about maybe writing information to some files, maybe sending information somewhere, or just finding out the overall size of the text or an object that stores some data, you would need to have an option to find out a size for the text and size for generally objects. In this case, it's only about the text that could give you a size in bytes. So size in bytes. Well, what does it mean? Nowadays we use different encodings of the texts, but each of those encodings literally makes it possible to assume that specific amount of bytes represents one symbol. Probably you have seen, guys, maybe in databases, maybe in old systems, if you were using them, definitely. If you didn't, then you didn't have this experience. You can find out the text which primary was written normally, maybe in non-English language, is being split in some different and let's call it strange symbols. And we have, in most of the cases, approximately doubled amount of symbols. Well, it's particular case when encodings of texts are not correspondent in the systems. So, literally UTF-8, which is mentioned here, just the text encoding, which literally means that each of the symbols takes particular amount of bytes. And all the rest encodings works in the same manner, and there is only one thing which is different between all of them is just a different amount of bytes per a symbol. That's it. That's the whole magic. And in a Python, we can make fast conversions of the text. So we using the text itself. It could be variable, like in this example, or we could place text into brackets, and then we could, after the brackets, write point, encode, and so on. So encode function allows us to convert a text to a specific format. Okay, and the len in this case gives amount of um, symbols. Well, such thing could work or could not to work correctly in different scenarios or in different modes of the Python. So you have to just know that most of compilers and interpreters like Python, they could have different modes, and between the modes, mostly there is a strict mode activated for most of such modes. So it's kind of a default one, and um, and kind of not strict one, literally. Um, Literally allows you to how to formulate this. Well, literally there are two ways how to get the size of the text. One gives you in a strict mode, one gives you amount of symbols, another gives you um, amount of bytes. If only you're using a so-called non-strict mode, all both of them will give you amount of symbols. So yeah, so primary this len will be working correctly. If you make modifications in the language mode, then you have to just consider problematics. Okay, so nextly we have amount of memory used by a variable. It really means that um, we're using a variable, and it's not related to a data itself, which is stored within a variable. So if you would need to find out what amount of memory variables takes, so you can get a so-called from a system library function get size of, and then there will be a variable. For example, some of you could say, well, I have variable 2, I have variable 3, they're the same. But at the same time, true and 100 takes a different amount of memory. And that would be totally correctly, and it would be a really great question because it's really so that they take different memory. But variable itself takes at least 28 bytes. Okay. All right. The next one. Well, for example, we would need to find out a so-called anagrams. Okay, so the anagram is the word obtained by rearranging the letters of another word. Literally, it means that if only two words are anagrams, so it means one is constructed of another's full set of symbols. Literally, that's the idea. And for this purpose, we can use a spatial class called counter from library collections. So literally collections is a folder, and the counter is the file in installation path. We can try how this one works. And let's maybe print out the result of this anagrams function. Yeah, so we received true. Let's make some modifications. So let's suppose we'll have 2 written in addition as a distant symbol. and definitely we receive false as the result, which is pretty obviously. Okay, a certain of the list. So let's suppose we have a list and we would need to sort them. As you remember, we have literally two operations of the sort, like the sort and the reverse, right? Literally, such thing is applicable even with a sorted um, function, and the sorted function literally assumes that we give a list and we give a direction of the sorting. Well, literally here we have a reverse equal to true, which literally means that we are setting true to value to the argument called the reverse. Well, maybe this written form is kind of weird, but there are other programming languages like Visual Basic, which asks the same, at least assumes the same way of giving arguments to function argument names. So this is kind of normal written form. We can even check that actually we can copy that, we can put that into the file. And yeah, so we can just make a printout, an execution, and we have the result of the last operation, which contains a function sorted. Well, if you don't mention this reverse, well we can actually assign false. But if we're using a default value, we can not to mention the value itself because the sorted function has a default value for the argument reverse. So, and as you understand from the current example, that value is for a scaling type of the sorting. Okay, dictionary sort. Well, I'm not really sure that this one will be pretty needed. At this point, maybe we can just, you know, we can just scroll that. Okay, but about indexing and spatial functions. Well, I suppose we remember that. Um, so maybe here to we wouldn't need to um, spend a lot of time. The only we have to remember that spatial functions they can affect our data structures like sequences in a way that we'll be having um, uh, modified version of them. For example, let's make three printouts. We'll have a full list. We'll have a one element, and we will take a look what we get in the end after accessing that element by the function pop. Okay, so what we got? We literally got it out from the array. Why? Well, because the pop function literally means that we're getting element out from the end. So it's not only giving you the value, but it's even taking that out. Okay, so here we have the case when we have some arrays, and then we have a text. Oh, I suppose that there was the print function disappeared. Um, yeah, looks like. So I suppose here it had to be like the print, then my favorite programming languages. and then there will be a separation of the printable results. But the most thing, guys, here, what I would like to highlight is this construction. So by default, we can actually convert an array to a text. I suppose that could be kind of understandable. Also, some of you could say, okay, we can print out the array, but literally, we're not making a conversion to the text by printout. We just by the printout go through all of the elements and we just pull them on the screen. That's it. But this particular case allows us um, to use a join, which is meant for the text. And here we have the text, and here we have the array elements, which will be converted to the text, and between them there will be this text pulled. So it means that for the separator, we say to which array elements, converting them to the text, that text will be a separator. Literally, that's the idea. Well, we can take this code. We can add the print which is missing here. Well, this is the part of the comment, so let's just erase it. And let's see what will be pulled on the screen. So you see, right? So to the separator, we give the array between which elements that separator will be placed, and the whole array will be converted to the text. That's the idea. If you would place some another element, for example, the vertical line, it would be the vertical line between them, like this. So you see, it's pretty easy, but again, construction itself maybe it's not really obvious. But again, that join was the function of the text. Okay, let's go forward. Okay, here we have the palindrome, and moreover, we will be looking for Python specific things. So here we have, in addition um, to the sequence taken by the begin index and ending index, we have a third kind of index which represents the way of data sort. In this particular case, we are finding out if the text is the palindrome. Well, texts are comparable in the similar manner in most of programming languages, so I suppose there is no need to talk a lot about this. But here we have the original text, and here we have the text which is taken from the first index to the add-on index, including on both sides, and we using the reverse sort of them. So how can we get how it works? So let's maybe make some printouts, um, like this one, and the second will be the reverse one, just to make sure that you understand how it works, and what this construction give you back. Just the text in the reverse direction. But let's see if it's really so. Oh, maybe I didn't save. Oh, okay, I didn't save the file. Yeah. So you see, we have a printout of the original way and reversed. Again, original and reversed. Also, we didn't have the palindromes results on the screen because we didn't have the print functions. But anyways, we will have them. Yeah. So you see here both texts are same during their comparisons, and here both texts are not same. So again, based on the comparison of original and reverse text. All right, let's shuffle. Um, okay, well, sometimes we need to mix elements of the array, and we need to do that in a so-called a random manner. Surely, for that purpose, we could make our own randomizer. We could go through the array, find out a new position of the element, and so on and so on. But this thing is not really needed because we have a spatial library, a random, and within that we have a file shuffle that has a shuffle function that literally implements the randomization of element positions. Let's maybe print them out, and we will see that those elements will be located in the shuffled arrays, in the shuffled sequences, not in their original ways. Okay, let's take a look how that works. Um, okay, why both of them give us none? Okay, why do I have both none? Yeah, without the print there should not be the printout. Well, that's kind of tricky. That's kind of tricky. Okay, names are correct anyways. Okay, I've no idea what happened in the wrong way, but okay, let's just move forward in materials because we have the time pretty limited. Okay, regular operations for upper in the case and lower in the case of the whole text. I suppose these functions are implemented in every programming language, so there's no need to maybe overlook them. It's kind of self-understandable. Next line, we can have insert into the actual text. It's something similar like we can insert equation into pre-written text in C language. Um, so idea here is pretty simple. We're using square brackets, and we say that data will be written in the first, second, and so on and so on. Sorry, not square brackets, but curly brackets. So data will be written into them. Something similar can be even um, found out in probably C++ printouts when we use um, uh, printf and we use a template where we use, for example, percentage sign d, percentage sign f, and so on and so on. But in reality, you could just concatenate values in a textual way, and that's it, and that would be enough. Okay, so going through elements of a sequence, I suppose we have to be good about that because that's pretty simple. In this case, we're going through every element of the array, right? And it's being placed into variable p for both of the methods. And within the first method, we find out within the text the word Python. And in the second method, we are finding Python in the text. So regularly you have seen this construction already and we use that. Okay. Sometimes, and moreover, this is related to the printout within the Python. So we can have several texts, and we would like to just print them out. But just printing them out puts a new line symbol in the end. So how to avoid this? And again, there is so well, since the print is a function, it has several arguments, and one of those arguments is the and by default is a new line symbol. So we can replace that by the empty text, which has none of the symbols, and that means that after the print on the text, that cursor on will be left after the position of the last symbol printed. Okay, well we can take a look. We can take a look how that happens. So there will be a first text, and there will be a second text. That's for the function of the print. Okay, but as you understand, the printing function prints you an information into the basic interface you're using. In our particular case, it's a CMD window, which means that well, it's just a command window. In the same time, we have overly four more streams. Um, well, overall, we have like a four strings uh, for managing the data plus files as the stream. And here in the beginning of this example, we're using sys stdout to write. Well, what is it? For example, sys is just a library, like a system library, which is pre-implemented for the Python. Stdout is literally it's a reference for the regular interface, and your regular interface is the terminal. But in addition, there are two more channels. STD information, if I'm not mistaken, STD info and STD error, like STD error. So they are printing information. They could print the information if your system is configured so in different colors, like yellow color for the info, red color for the error, and so on and so on. And you as developers, you can even create for each of these streams a different output. For example, the regular goes to the terminal, and error and info messages will come to specific files. All this is configurable and it can be done. In addition, such simplified streaming things, they have a lot of different functions for making modifications of how data is being sent. Well, if I'm not mistaken, we can have a write ln for printing out the data and pulling a new line symbol in the end of the print. Let's take a look. I'm just thinking it's implemented in a such way. Let's just find out if that's correct. Oh, okay. Right len is not the case. Okay, then we can try to use that combination we know, or if we're using UTF-8 on the Windows, we can use /n/r, and if we're using Unicode, then /r/n. But okay, let's try. Yeah, so as you can see, uh, a new line was placed because this /n/r goes for the Windows. If we will leave just /n, I suppose it will be executed as well. Well, yeah, because every system knows that /n. Okay, about fragmentation, I suppose we won't be overlooking this, because this is kind of maybe not really usable from the beginning. Okay, so as you can see, a lot of cool things can be implemented, and a lot of methods are created within a Python. But again, all of them are pretty simple, like the basic operations. It's kind of nothing really special. The only thing how you implement, and it's only the matter of the training. Okay, but making the apps more nicely looking and more preferable for so-called potential clients who could use them, you need to be able to make an interface which will be liked by users. And the only option nowadays for this is just making the graphical interface because no one would like to work within the CMD window. I suppose that's pretty understandable. Okay, so we will be moving forward to the GUI presentation about the visual side. But do we have any questions about things we took a look at? Okay, so we have Iveta here. Hello. Um, okay, and still we are not kind of in the full set, but okay, it is what it is. So, do you have any questions so far?
I don't think we have any questions. It's just gonna be hard to remember all those methods and stuff.
Okay, okay, good. All right, then let's move forward and let's take a look on the graphical interfaces. And we'll be taking the most simplified library, which is by the way pre-installed, so you can get that after just after the installation of the Python. Um, all right, so here we have it. Okay, so we'll be taking a so-called Tkinter library. So Tkinter has several implementations actually, and one of them is being done for the Python, and somehow Python just took that and included into its kind of default installation set. This library is not complicated, but unfortunately, you have to be coding for your interface. It's not like in Visual Studio when you just drag and drop elements, or maybe like in the Delphi when you just put them on the form and you get them. So so it's a bit different. The first of all, we have to consider that there could be two types of an execution of this Tkinter. Since in the Python the uppercase letter is not the same as the lowercase letter, so they're different. We have to firstly to get which one of the Tkinters we have, and especially they will be different if you will be using a different versions of the Python. For example, if I'm not mistaken, here on the top we have version number 2, and here on the bottom we have version number 3. How they're different? Well, by the uppercase and lowercase letters of the library name. Uh, but if you get incorrect one, you cannot. Well, Python cannot get that. So all examples footer will be only in the Python 3. And maybe, and by the way, what will be a result of this one? And how, and what is it actually? Well, we will be making elements by the pretty understandable names, I would say, of the classes, which will give us instances of elements, and those instances of elements will have to be hooked for the main window and the sub elements of that one. Surely that happens by references. And since every of such windows, they are looking and let's say waiting for the input, and they are analyzing what exactly was pressed, like what was affected of the GUI elements, and then based on that conclusion of which element was affected, uh, we can write the code which will be doing something corresponding to the element affected. Such method was implemented for graphical interfaces and just Windows system for well within within the C language, and there was such thing as a waiting loop. Like there is the function is gonna be executed all the time, just finding out if user did any event, like pressing the button, maybe scrolling the mouse wheel, and so on and so on. I assume that such methodology was taken even for the Python, because here idea is that we're constructing all the elements and then we run that loop of the main window. Actually, we have to do that for every window which is separated, but in this example we have only one, and that will be pretty enough. Yeah. So this one will just give you a small window. Let's try to see how it works. Oops. To see how it works. Yeah. So you see, we have a Kinter icon, and we have a small window. Oops. I will close that WhatsApp so it wouldn't disturb us. So you see, we have it, and we can actually resize it as we wish. We can move that in a way we like, and we can even close that. But you can see that in the terminal in the CMD, we didn't reach the next command input because that application, the CMD, is stuck and is waiting until the moment when we will close the application, and we will be given back an error code of the Kinter this waiting process, or let's call it execution process. So that's the idea. And that size which we have for that window is a default one, which is not necessarily will be implemented and used once we will pull inside whatever element. For example, we can take the next case, well, which is the button actually. So here we have the button. It uses the class button to create an instance. The result will be exactly that one we see on the screen. So we will have the button, and we can even click that, and we can have some of the events, for example, showing the modal window with the text. So let's see how that works. We used Kinter library itself, and we use particularly message box, which is a modal window. We have the function hello callback, which literally shows a modal window with a header with the regular text, and how that hello callback is being used. When we create the button, given a text, we give even the function which will be executed. But for that function, we don't have to have uh, arguments. Nextly, we kind of compile that button, and we just run the main loop. So there could be a question. Well, how this button is connected to the form? Well, it's more than obviously because we give the parent element's reference as the first argument of the function, and the same principle will be used for other elements as well. Okay, let's see how that works. Let's copy all this. We will have to erase those enter signs to guarantee that the comment is written into one line. Okay, and let's run it. So what we see, guys, we see that actually a window size was changed, and it was changed correspondingly to the content of the window. We have a button which has its own height. So the form's height was the button's height, and the width is being tried to be used from the button. But the button is so small and is smaller than the minimal size of a window. So you see, even these three buttons, they didn't fit inside that size. So the window cannot be smaller than this what we have here. And surely let's find out if the callback works. So let's click hello. Yeah, and you see we have that information window. Well, pretty simple, I would say. Okay. Sometimes, and by the way, this is pretty common thing. We can have a drawing as on the canvas. Idea here is pretty simple. We can have a function which literally repaints the window, and we can have for each of the frames, or maybe when the window has been refreshed, we can just draw any figures. For example, we can have some arc, or maybe polygon drawn, and so on and so on. Okay, so let's take one, and let's see how that works. Yeah. Okay, so we'll be having the canvas, which will be located for the main window. The background color will be blue, but we can give those colors even in the code form, and we have the particular size of this canvas. Next, we create the arc, surely on the canvas, so you can see we have variables here, right? At the specific coordinate, and surely such create arc has additional parameters, like the color, like like the field color, and um, the beginning angle, um, the size of the amount of the angles which will be drawn within this arc, and so on and so on. Maybe this example is not really interesting, but it depends on figures you would like to show. And as you can see, we specify the size of the arc, right? So it's not binded to the window, right? By the way, there wasn't mentioned an exact position of the canvas, but the idea is that firstly, or let's call it by default, it's located on the top middle position. Afterwards, for other elements, you will find out examples of how to select this position. Okay, the check button. We need such things anyways within interfaces because we're gonna ask users for selection of something, like how to show data, maybe to activate filter of data, not to activate the filter of data, and so on and so on. So what do we have here? Well, we have the check button, and as you understand, we have to somehow get the result of this check. So for that purpose, we need to have variables which will be gettable from interface. So for that purpose, we can have a variable, for example, of data type integer. And in this case, we are working with data types, unfortunately, which is not the standard of the Python, but it's the common sense because check button can be checked or unchecked, or there could be the third state, which is called gray, when it just has none of checked and unchecked cases, or just unknown. We can call it in that way. So again, we have check button. It's binded um, to the window. It has its text and it has a variable which value will be modified once we affect this element. And we can set up a specific values for 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 each of the states of the checkbox or check button. As well as we have the size of the check button. Well, similarly here it's implemented for the second check button, and as you see, both of them are packed like compiled or prepared. We can call it in a such way, and then the window is being activated. So let's see how that works. Okay, here we have common continuation symbols, like we are continuing the current command on the next line. Okay, let's run the code. Yeah, and as you can see, we have one and another check buttons. Um, an entry. In most of the cases, user has to type something in the applications, right? So we can give a text box, which will be an entry in this case, and we can even give another element which has the class of the label. So let's see how that works. As you can see, we're using the label, which is just a regular text written, and we say, okay, that text will be pulled into the main window, and it will be placed on the left side, vertically on the in the middle, if I'm not mistaken. Next there is the entry, and the entry has a BD argument, and that BD argument is actually the border size. So as more you pull, the bigger border will be around the textual block. And now then during the preparation of this element, that will be placed on the right side, if I'm not mistaken, in the vertical middle. Um, and then the main functions being run. Okay, let's try. Let's try how that works. Yeah, yeah. They're located in the vertical middle. Okay, maybe let's modify the border size just to be sure that it, that we don't have to maybe play a lot with this parameter. Okay, here we have a much bigger border size. Well, looks like nonsense, but actually you can do this. Okay. Um, Probably you have seen if you've been working with maybe Visual Studio or maybe Delphi, that in most of the cases, especially for the drag and drop application creations, we can have a so-called grouping of elements, and we can set up a specific behavior for the group element, like it could be the panel, which contains several elements, and then those elements are somehow structured, or let's call it sorted, between themselves within that particular panel. So such panels in the Python, they're called as frames. And we can have frames like in this example. So what do we have? Well, we will be having two frames. So we have the window, we have the frame, which is binded to the window. Next, well, as you understand, guys, since position for the pattern is not given, then it's top middle. Nextly, we make another frame and we put that on the bottom and horizontally in the middle. Then two frames are created. So we can put buttons into frames, and for that purpose we just mention those frames as the parent and element at the arguments on the first position. And then we just place in some elements. For example, text red, and foreground color is red. So this FG is the foreground, BG background. And here we have pulled that on the left, but on the left within the frame, not within the window. Next we have another, the brown button. It will be located on the left. So the frame has some let's say miracle left vertical centered position. Oh, why I called it kind of miracle position, because because we will see that only in the end when all elements are being placed inside. At this point, it's obviously where we have it, but when we have zero elements, then you can imagine that it could be somewhere in the middle, and once you place element, the panels being just extended to the right and left directions. So that's the way how we can understand this. And in a similar manner, other buttons have been placed, and the window was run. Let's see how it works. Let's try to run this code. So we have run this code. And again, let's maybe extend size of this one. And what do we have? Well, okay, we have panel on the top, we have panel on the bottom, and we have even elements. So, for example, you can see that if we replace one button, it's located in a such way because the left side of the panel becomes on the left side of the panel becomes on the left side of the button, and the same for the right. So it's being located on the right side of the button, which is pretty, I suppose, understandable. Okay, well, that's the example. Okay, so here I have separately written about the label, but you know we already overlooked that. So maybe there is no point to spend a lot of time for that. Well, if I'm not mistaken, we kind of have to have a break now. Let me check in the schedule if we have to have break. No. Ah, no. In 10 minutes. Okay, in 10 minutes. All right. So let's move forward. Well, the next one is the list box. Already one of elements which is pretty popular. So how list box works? Well, we can place elements inside the list box. Primary, they can be textual, but actually we can extend them to have some images inside, some buttons even, but that would be a bit more complicated. So let's maybe at least start with simplified cases. So we have the list box, which the parent element is a main window, and we are pulling inside elements. And once we created a data set, we have to pack or we have to prepare that element for the output, and then we just run in the main window. By the way, we can get access to elements which are selected in such list. So let's take this code, let's save it, and let's run it. Yeah. So you can see we're getting the marker on those records, right? So this is pretty nicely working. Okay, another fancy thing is the menu. So we can create the menu, which literally is a kind of pressing the button to receive a list of options. Idea here is pretty simple. So, for example, we having checkboxes into such ones. So what do? We create the menu button. Okay, it has its name, and we have the relief. So literally, we say that it's been raised. Okay, the list of such buttons is being uh, created. Um, and then we have to create a so-called content. For the content, we're using a so-called menu. And for the menu, we just add in an elements. For example, check buttons, or it could be the button, it could be the text, it could be maybe a radio button and others. Okay, we have the name, literally the text which will be written there, and we have a variable which will receive the value after some changes. After someone will click that button. And the same for the second button, then the menu is being prepared, and then the window itself being shown. Let's see how that works. Mhm. Okay, so we open the menu and then we can literally pull checkboxes for options we like. Surely we could even use mm, we could even use callback functions. That would be useful, by the way. Okay. Well, the next one is maybe not really interesting one, but it's kind of the label with a possibility to be a bit modified. For example, here we have a relief parameter, which we didn't use for the label. But the main idea here is that we can be working on the multi-line texts. Okay, maybe it's not very interesting, but we can run it and take a look how it works. Maybe the another pretty simple thing is that we would have a variable which again will be binded um, to the text shown. Yeah. So here, for example, you could have some status text, for example, and when you click on some buttons in your application, changing some statuses of your app, of maybe some products, you will instantly have the statuses, for example, shown in such elements. Okay, well, maybe not really complicated, but a lot of but a lot of small elements are implemented. Okay, well, previously I mentioned that there could be even radio buttons, and here we have them. Well, idea here is that we can have the radio button, and well, when we have a radio button, we make an assumption that user has to select an option from the set of options we provide. So, which means that in most of the cases we use at least two of radio buttons for a particular question, for the particular selection. So, and we can always get which radio button is being activated. So here we have the code. While selecting the radio buttons, we'll be printing out the text of which option was selected. For that purpose, we'll be using function cell. And idea here is that function cell will give us a value from the variable var. But what exactly is variable var? Well, that's Kinter's variable, integer variable, and that variable will be used for placing the radio button's value. Here you can find out value 1, value 2, value 3 into variable called var, which has been implemented here. And the command for an execution while we clicked or while we select the new state of the radio button is the command called cell. And we have a function cell, so that's we will see text changes on the screen on the form. Let's see Let's see how this one works. Let's copy it. Let's put it inside, and let's maybe guarantee that everything is placed on their own lines, like this one. And let's run the code. What did I do? Okay, yes, this one happened. And the label config. So yes, I missed that thing. Okay, so let's click them. So we have option 1, we have option 2, we have option 3 select. So you can see how the text is being changed. Well, maybe looks nothing really specific, but you have to provide such interfaces for your application users anyways. Because these things works and this is just click 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 style work and not just typing comments. Okay, so let's take a 10 minutes break then guys, and let's continue after 10 minutes. Okay, during the break I will switch off camera and microphone. Guys, are you ready to continue? Okay, great. Okay, so let's move to our materials. Yeah, so the ready buttons. Well. Again, we tried them. We can have the response activating them. Actually, that selection could be working even if we would be just clicking them, I suppose. At least if I'm not mistaken, it was implemented in that way. So if you would have something changeable, like how many times it's been clicked, then definitely you would get some updates in such text as well. Maybe we can even make that just to check if that's so. So let's maybe create maybe some variable. Let's call it maybe x equal to a zero. Here we would be maybe increasing the x with 1, for example. Then we could, for example, here um, have this value, maybe in a such way. We could create this. Let's just try. Okay, so what do we have? We have uh, right. So not associated with the value. Um, Theoretically, what we could do, we could create um, maybe an x in a such way. Here we could have set 0. Nextly, we could have set x get plus 1. Maybe this one would work. Let's see. Yeah. So if I use this approach, then I have to have this x gap, not just x. X get. Okay. Yeah, it's integer, so it gives integer in a strict form. Yeah. So we have to make conversion to the string. Okay. So we have it, and you see we're clicking that option 1, right? And the value is being increased still. So that function happens, or let's say is being executed, not only not only when we select, but even when we clicked already selected item. So I suppose that's pretty understandable. All right. So what else do we have? Um, the element I personally use very rarely is the scale. Well, this one can be used in combination with other elements, but when it's just a single element, then it's really hard to find out appliances for this. So here we have the scale. All the rest elements are known, like the label and the button. An idea here is that the scale has the minimal value, it has the maximal value. Um, if well, we can even not to set up them from the very beginning. If I'm not mistaken, it will be then from a 0 to 100. And we have a scroller which we can pull by the mouse or by the buttons up and down arrows. And by moving that, we'll literally change the value of the scale, and we can get that value actually. For example, here you can see that we make in the scale. We say that a value from the scale will be written in variable called the var, right? And then we use this variable right there. So we take that variable and we just show that in the label. That's it. Yeah, so let's take a look how that works overlay. Okay, and let's make the full lines like this one. Okay, so what do we get? Well, we can choose a value from 0 to 100 because we didn't set up minimal value, maximal value, and we can get the value and put the text on the screen. Surely, behind that buttons click, there could be some other code that somehow uses that value for some other purposes, because this is just a simplified example. Okay, so a scroll bar. Well, scroll bar here in the Python is being implemented as the separated element, which is assignable to other visuals. For example, here we see a list, and here we see a scroll bar, right? They can be combined between themselves. Here we have an example. So we have the scroll bar. Okay, it has its root element, the window itself, right? So that's why it's located here on the right side of the window. And we pack that. So we pull that on the right side, and we say that okay, that will be located vertically. Next, we have the list box. Okay, again, um, it has its own parent element. And for the scrolling, we will be having the comment from the scroll bar. This comment works um, in dual mode scenario. So when this comment is being set, um, we can move a scroll bar, and by that we'll be moving even the list. Or we can use, for example, arrow buttons, and we can go within the list on the bottom. And when we will be doing that, the scrolling bar will be just scrolling. Let's see how that works. All right, looks now is good, and let's run it. Okay, we have it. So as you can see, the scroll bar scrolls the list, and I'm pressing now the arrow on the bottom, and as you can see, that position of select element even scrolls the scroll bar. So as you can see, it works in the dual way mode.
Sorry, but can you use a scroll wheel to move it? Will
Uh,
it work?
yes, you have to be. Let's check. Yes.
Oh yeah.
The next element, which is Uh, well, sometimes it's pretty complicated to set up this one correctly. But you have to know that. Oh, and by the way, we have to think about encodings for this one as well. But you have to know that it's possible to have the mark text. Literally, it's the text which you can color, which you can affect graphically. The only problematic here is how to measure parts of this text. Um, for example, what we have in this particular case. Well, in this particular case, um, Um, in this particular case, we have text element, and we fill that with text. Okay, well. This is good, but it's interesting how can we make any highlights. So we have to make a specification. All right, a specification here has been implemented in a very interesting manner. I suppose we can even count amount of symbols, but these parameters, they're not exactly um, float or double numbers. They are a combination of the line and position. So on the first line, we're working uh, on the cursor before the first symbol, and overall we are going till the symbol 4. Okay, here we go, starting with the symbol 8, and we go to the symbol 13. Primary, such thing which we have in these two code lines, it just makes well, it does literally nothing besides the fact that it says, okay, we have a region which could be possibly affected. What does it mean, could be possibly affected? If you're losing this region from your text, nothing bad is happening, basically. For example, we can erase the text, so we can like use a remove or whatever other function, and if we will be trying to colorize those elements, those text fragments, it will be just ignored. Which is, by the way, pretty good. Otherwise, working with such element would be a real disaster. Literally, we can take this code, we can put that inside. Let's fix those rows in a such way, and let's run. No, something is missing. Um, yes. Okay, but where do I have this on click? Ah, okay, maybe it was just a leftover from some other example. Okay, so 4 is being selected for the first coloring. Then we allocated before the 4, before the 5, before the 6, before the 7, before the 8. And okay, now it's not really obviously, but I see the cursor on my screen, so it's before the 8, 9, 10, 11, 12, 13. Yeah, and you see the cursor is blinking. If I will pull the cursor on the right side, you see it just went out. Okay. Um, well, a top level. Sometimes, guys, we need to work with multiple window case and multiple window application. Most of applications are multi-window. So you can be working prior, let's say, in a one window, and suddenly a user would need to open some additional module where you provide your user with another functions. So user opens that, and we have to guarantee that previously uh, unsaved work still should be available on the screen. So we make another window. And once user finish the work with the first window, sorry, the second window, it closes that and returns to the first one. And this is guaranteed here by the top level class. Literally, they are both the main one and sub window. They're using in a similar way. So you can use buttons, you can use other elements in the same manner, like for the main one. So there's no difference related to a usage. The only thing you have to say that there is still a top level element. Sorry, top level in this case is kind of a sub window. So you have to still have the main window, and you have to be holding this unclosed. So once you have several windows and you close the main one, the full application closes. But once you close the so-called sub window, then the main one is still appearing on the screen. So that should be just taken into account. Maybe when these windows are empty, it's not really obvious which one is which. Okay. Um, Well, most likely, I would say that, okay, I have the window and then I created the sub window. So a disabled one might be the main one. So here I have a disabled one because this minimization, maximization, and closing signs, they are active for this form, right? For this one. So it means that it's a sub window. I can close that. Okay, maybe I did double click and then I click on this terminal. Okay, so sub window is closed, and here I have the main window. Okay, I can close the main window, and you see, I gave to the CMD the code of execution. So again, here we have a main window because it's been kind of not placed in non-active mode. We can close that, and you see all everything related to the program is closed, and we are back to the terminal. Okay, let's move forward. The spin box, pretty famous thing, just to select the value in the ranges. So most likely for such elements, we specify ranges between which user can choose the value. For example, we will set the minimal as a 0 and the maximal as 10. So let's see how that looks. Okay, so the maximal is 10, so we cannot have more, and we cannot have less than a 0. Surely we can try to write, and trying to write is not prohibited here, so we can do that. Surely there should be a tons of other options. For example, disallowing to write something inside, because you can see we can write whatever value there, which is not good. So we can look for options. Okay, well, I think we're good so far with this one because this is pretty simple thing. Okay, the pen window. Well, it's something similar to frames, because again we can place frames on the form, sorry, in the window, and we can make a so-called pen window. Literally, I don't really have any, um, let's say, preferences between the that form and pen window. Um, well, maybe it's more related to which way is easier for you to use, or which one you remember better. Okay, so we have them. We can pull texts and we can run them. Yeah. So literally it would be the same as having frames. Yeah, but only it's kind of the frame with the label inside. Yeah, maybe we can call it in a such way. Yeah, the label frame. Well, this thing is mostly used for grouping visual elements in a lot of solutions like a Visual Studio or Delphi, maybe Lazarus and others. They use such a rectangle which is drawn around the area, and there is the label written on the top of it. So this is pretty famous thing. And in this programming language is called as the label frame. So we have the label frame. We put that somehow, and we put a text inside. Well, because like the regular frames, open windows, they can be used as parent elements for other elements. So as you can see, all this is working, I would say, by the same scenario mostly. The main is just to remember the main principles, how this works, how elements are being placed on the form, that they are positioning, differentiations, and so on and so on. Okay, so yeah, this is the last slide of this particular presentation. All right. So I suppose this might be pretty simple from my point of view. Okay, but maybe we have some questions related to this.
I don't
Okay.
know. As you said, it's not that difficult.
Yeah.
But as I said before, there's a lot of stuff to remember, and I will keep saying this a lot because there is a lot of stuff to remember, and I don't think that like one or two lessons will be enough. And I think that we will need to like search for the same information twice on the internet or something. Maybe
Believe it or not, once you will try to implement this, you will remember this as this one.
well, I hope so.
Well, it's really so. Okay, we have around kind of 55 minutes left. All right. Well, I wouldn't like to overload you with some info. I suppose I can ask you to implement a small application during the time left for the class. So guys, are you working on your computers where you have Python? I mean, are you capable to make applications right now?
Well, I am, yeah.
Mm-hmm. Okay. What's about Davidus? Well, I guess silence means yes. Okay. Okay, that's great. So okay, what happened? I asked if you can make applications right now because we finished the GUI, and I would like to just ask you to create a couple of applications at this moment, just to try those options we overlooked today. That is a good answer. Okay. At least you can try, I would say. All right. So maybe I will need to have some notepad. Yeah, to make a definitions of what I would like to ask you to do. So the first one, that's the app that calculates x in no, x in the power of y when x and y are selected by scale. Let it be the first app you would need to do. Overall, I suppose there will be like a 3 or 4 apps. Alright, so the next one will be an app. Well, maybe I can just not to write the app itself. So nextly you will need to um, okay, so the second app has to contain um, two frames. One will store 5 buttons horizontally, and the second vertically. Well, not nothing really complicated, but you will need to think, well, how to do that. Okay, the next one. The next one will be a menu with food ordering list and the app. Okay, list with prices, and the app should calculate the total sum per pay for the meals. Oops. For the meal, yeah. Okay. So maybe I can assume that you could make maybe at least these 3 applications. Is the task clear for you guys?
Yes.
Okay, so please try to do that, and once you will complete that each of them, right? You can put the code in the chat, and I will take those codes and I will check if they're implemented correctly, or at least as it was defined here. Okay, I will put that just in case in the chat, so you would have it in any case. I'm in these tasks. Yeah, and maybe I will just keep this view open so to see your codes if when you will be copying them in the chat.
The first one that says X is that
X
risen
in the
by
no, it's power, so it's powered by Y. And Frank is saying there are 2 solutions for this. You can use a for loop, or you can find out a powering function.
can you define what tools I can use for information searches?
Google. Okay. What about to search for? Okay.
I mean,
Yeah. Go on.
everything. Like
Everything.
there's 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 sites that help you write stuff.
Oh, the only thing, don't use the chat GPT for all this. Because it wouldn't be primary fair, and secondary, it wouldn't work well as the study process. Okay, so what would you need to use? So since it's defined to use the scale, right? So we can go for the scale, and example which you have here actually already has the button. So once you'll be choosing one or another value from the scale, you'll be clicking the button, for example, and within the text you will be placing the result. That's one thing. Another thing that you would need to add another scale here, and that's really up to you. Actually you can think how to do that. You can make the frame upper the button, and you can place, for example, two scales there. Why not? This is pretty possible. Or you can use, or you can put there two scales on the bottom of the frame and two labels on the top, writing for the first one X and for the second one Y. So this example could be kind of the starting point. Does it make a sense?
Yeah, I think it does.
Okay, okay. Edward, how's your progress? Because I see that your friend is kind of disappeared, so maybe it's too complicated. Okay, I see that you activated the microphone, but you're not speaking. Uh, so again, you don't have to be shy to ask because if something is not clear for you or you have no idea how to make, you can always ask.
Oh, I'll fix my microphone. I don't know what happened. So yeah, I I've done the scale part, and I want to add like a text box where you can put a number in.
Okay, so you can just create the label, um, according to example, right? So we can have the label, just a regular one, and you can always change its text. So you are assigning label to the variable, right? And so you have variable, you run config, and you say that text will become a new text which you like. Does it make sense?
I mean, it does, but I don't think it really got me anywhere. Just a
Uh,
second.
okay. So let's take a look what we have. So let's suppose we will have a scale, and let's say I would have something like, I don't know, maybe a value in the power of two. Let's suppose, right? So how this could be done? Okay, we can get the value, right? And if we would like, let's say, to have the power of 2, would be just, multiplying the value with itself. That would be the second order, right, of the value. Okay, that's good. So we can even make something like, you know, where is, well, even something like this. Okay, if we would run that, we could say, okay, let's say 4 in the power of 4. Ah, no, sorry, square. So it will be 16. Would you agree that 4 in the second order is 16?
Yeah.
Well, yes, it's so. So what would we need? We would need to add another scale, and that will be, another value. Okay, let's make it super simple. Let's just make the scale. Let's suppose you would have just a scale 2. Let's call it that way. A scale 2. Okay, looks great. And we will get the second scale value into variable 2. Okay, good. So we will have the value, um, first one, and the second will be an order, right? Sorry, not the order, but a power. Okay, so we'll be getting that value as the var2 because it comes from the second var, right? From the var2. Okay, and what's then? Okay, let's fulfill this with a full equation signs, right? Like power and equal, and that's it. So the value in this power is, and then this result. No, sorry, not this one, but we'll need to find out the power function. Okay, since I'm not using this for the math things, we can just fastly Google that. Python power. Okay, okay, so it will be just this thing. Okay, looks great. So, what we'll be doing? So, the first and the second. That's it. Okay, looks awesome. And let's see if we are successful with it. So let's suppose we will have 9 in the power, let's say, of let's say of 3. But let's say we will have something different. Let's suppose it will be 4 in the power of 3. It will be 16 by 4. It will be 40 and 40 and 24, so it has to
64.
be 64. Okay, let's see if it gives us correct result. Well, yes. 4 in the power of 3 is 64. And that's the solution.
Okay, hmm, I thought that X needs to be written in like a text box, and
Then why do we need a scale?
yeah, yeah, I misread it. I thought that only like Y needs to be on the scale. That's my
Okay,
mistake.
okay. Let's say you misunderstood. I suppose you could need that code, so I will be just copying you this code in the chat just in case.
Okay, thank you.
Okay, so maybe you can make the second one then.
I will try.
Okay, try it. And again, once something's not happening, you don't have to be shy to tell. I will help you. I will show you how to do things. But firstly, try it on your own.
Okay. Can you check the chat?
Nothing is there. Ah, no. Yes, it's hidden. Yeah, let's see. Yeah, that's good. That's good. Mm-hmm. Cool. All right, then I suppose it's the time for the last task. So, for example, you can use checkboxes for this. So it's kind of just a menu, the checkbox per each item, and each of them has its own price. And you can just, make a calculation of the full price for the order.
Okay, I'll try. I don't know. I give up.
You give
I,
up?
yeah, I don't know how
Oh,
to give the values to the selected checkbox and add them.
oh,
Like I've made the
okay.
checkboxes for
Um,
different checkboxes, but
all right. Then let's see. Then let's take a look how it goes, right? Um, okay. Well, again, according to examples. So we had example related to checkboxes, right? Again, we can take that as the primary example if you like, just to
I did
make
that.
it just to make it easier for you. Okay, so let's say we have I don't know, French fries, right? Let's say if we checked. Well, let's suppose there will be a value. Let's say we will be placing let's say prices in cents. I don't know. The cost of the French fries. I don't know. Okay, let's say €2, right? So 200 cents. Okay, then what can be there? Uh, okay, so some burger, no difference, right? Let's say 300 cents. Okay, so we already have this values in such variables. The only thing is missing is a button. Okay, again, there is nothing to um, nothing to struggle with. We can just um, take them even from the example. Let's suppose we'll be placing a button. Okay, it needs a comment. Let's suppose the same message box will be imported, and let's say we will be showing the message box once we press the button. Um, let's say we will have the calculate, and we will have total price, and here we'll be having the price. Okay, let's suppose it will be get plus or check what to get. Okay, okay, let's try to run it. Okay, let's say it will be just the French fries. Okay, 200 cents. Just a burger, 300 cents. Both of them, okay, 500 cents. Surely, we can make this euros and cents separation in a different manner. So um, we can even divide that with 500s, and we can make something like um, so-called data type, like strictly convert to a text, right? For example, sorry, division by 100, because in the euro there are 100 cents. Okay, and then let's rerun the app. Okay, so €5. Well, we can even write like a euros there. Does it make a sense?
Yes, it does.
Okay, do you need the code as well?
Yes, please.
Okay, so you have it. All right. Well, we have a few minutes left, so maybe it's time for Q&As if you have some questions.
I mean, oh,
Well, just things related to practicing, I would say.
yes. I mean,
Mhm.
we just need practice. That's it.
Yeah, exactly. Okay, so in this week we'll have one more class on Friday. That starts at 6:50. Yeah, probably at 6:50. Let me check.
Yeah, 6:50.
Mm-hmm. Yeah. All right. All right. And then the next week we will have classes on somewhere in November, if I'm not mistaken. I don't know why these guys they made such schedule, because maybe it would be easier to have a one class per week or something like that. But your study institution decided this way this time.
Yeah, it is a bit difficult to get back to learning after like almost 2 months.
Yeah. So, okay, but it is what it is. I suppose. Anyways, just afterwards you will need to make all of assignments, the final project, and things will be fine.
Well, let's hope so.
Yeah. Okay. So no questions so far, right?
No,
Okay.
you answered all my questions.
Okay, that's awesome. That's awesome. All right. So thanks for attending the class, and see you on Friday.
Right, see you. Bye.
Okay. Bye bye. Have a nice evening.
You too.
Thank you. Bye bye.